The next chapter we're going to take a look at is the fabric management and automation. Now, as we've seen, one of the stark differences between ACI and your traditional Cisco network would be the fact that the APIC is a central point of management. So that being said, let me identify the difference between these two commands. Show running config. Would you classify this if I were to give you two choices? Or I'm even going to write show running config. Which of these would you classify it under? If I were to give you these two choices and say, hey, pick this command, you need to put it in one of these planes. Where would you assign it? Felipe, you're asking me the question, or you're like, maybe. Okay, Felipe, things, maybe, management. Anybody else? Management, administrative, configurational plane, they all mean the same. Because the only way you make changes on the Cisco devices is in config mode, config T. Shell is classified it under the management plane. Anybody else? Nobody else wants to classify it. It's not a finite test. I'm not going to score, mark any, you're not going to get any scores for this answers. So you may take the, or go ahead and classify it in one of these planes. Boyd has classified it under management plane. Anybody else? We have 11 of you online. Let's hear from you. Only 3 answers now. Marvin says operational. Victor says operational. Okay, we got about 5 answers. Let's try and go. Show running config. I'm going to go ahead and assign it to this plane. Whereas show IP route, show interface status would be, why would I do this? Why would I classify it in 2 different planes? Anyone? Why have I done this? Why is this distinction? Or show IP OSPF neighbors? Thank you, Boyd. Config, or whatever you do through the config prompt, is saved and running config, but it doesn't necessarily mean that the system is actually running the protocol in an operational manner. Okay, so what do I mean by that? I may enable BGP on my device, but what if there are no neighbors enabled with BGP? Do you think my router would receive any BGP updates? The BGP actually be operational if there are no neighbors configured with. So when I look at running config, everything looks perfect on my router. I've configured it correctly, but it's still not operating correctly. Okay, operational is the commands which show you real time as it is right now. Is it operating fine? So given that there is a difference between configurational plane and operational plane, understand this. This is something you will need going forward for any programmability that you may venture into. And given that many of you are from larger organizations, there's pretty much no escape. That's the approach Cisco is taking. Okay, you may have noticed Cisco announced in Cisco Live, they announced all of these new certification tracks, completely programmability. You need to know the difference between what is a configurational plane and what is a operational plane. Okay. Now that I've highlighted the difference, if I were to ask you this question, show running config, on which device in ACI should I basically see the management or configuration? Switches or APICs? Where should I issue this command? Where should I issue my operational commands? Switches or APIC? So my configurational commands Boy, did you write switches as management and operational as APIC? Is that what you wrote? Okay, you meant APIC is operational. Let's see. Show interface or show IP route. On which device would I issue? We already decided show interface, show IP OSPF neighbors, show IP route. Those are operational commands. On which of the devices, APIC or switches, would I issue the command show IP route? So Victor, Felipe, we are all agreeing on, okay, now Ginger, your private messages showed up quite late here. So switches is operational. APIC is configurational or management. Haven't we agreed? This is the central point of, or only point of management. Any questions, any clarifications needed? Identifying this difference between the two planes and why we definitely have to identify the difference between the two and know where these commands should be issued. Okay, so now that we know that the APIC is your sole or only point of management, that would be the only device where we configure or manage or administrative changes And you can also, APIC collects health information or telemetry information. It's a point of collection, so it knows how these devices are functioning. It also means APIC is the only device through which you can do any kind of image upgrades also. Okay. So we've already arrived at this conclusion. Single point of administration is your APIC cluster. The switches are stateless hardware, and based on the desire of the administrator, based on the final outcome, the network engineer or the administrator specifies the configuration required on the APIC. The APIC saves it in its model, the management information model, and then sends messages to the switches to arrive at the desired state. The GUI of the APIC is HTML5 based, so you don't need any plugins like the old APIC would be Java based. You would have need plugins, or not APIC, but older applications. The GUI provides access to all statistics, shows you faults, shows you audit logs, operational information, as well as configuration data. It provides you because it collects operational information from the switches, provides you access to your spines, your leaf switches, through a single sign-on mechanism. In fact, you can actually, through the GUI, initiate an SSH to those devices. The APIC actually has a REST API, an application programming interface, which is known as REST, R-E-S-T. This term, REST, is an industry standard programming interface that several vendors use. So it makes it easier for programmers or for developers to build applications. Now, you can always get to the command line of the APIC. I'm showing you the command line, of course. The APIC has, it's implemented in Python, and you have two approaches to configure the APIC. One is the NXOS-like command line. Another one is called the object model-based command line. This used to be the default. Not anymore. This is the default now. So if you want to switch to the object model-based command line, that's the command. Of course, you can go ahead and be very specific. Tell it that you want to see only commands particular to a certain VRF. Since it is built in Python from ground up, you can go ahead and automate this environment using Python scripts. Okay. So this is basically just showing you how you can switch to the object model-based command line. And you can see how they're actually using modeling, which is specifying the name of the tenant, unlike how you would have done it in the NXOS command line. Now, everything you configure in the APIC needs to be backed up. All the policies you configure, all the configuration data, Policies would be more like your contracts and all your interface policies and interface policy group, and all of that needs to be backed up. That will be done using the export. Okay. Similarly, you can also import. You want to go ahead and restore the system to some previous backed up configuration, you can do the import. Now, to perform the export, you've got to create a policy which can be run ad hoc, that means on demand, or you can say, well, export the configuration on a scheduled basis. When you go ahead and configure the export, remember what the APIC is doing, it's not backing up your data, so it's essentially backing up the configuration on the APIC. Basically backing up the configuration here. Now you must remember it's based on this configuration that it has sent instructions to the stateless devices to change their state. So this configuration here is very important. You need to back it up. And that's what they're saying. You can export the configuration on demand, more like ad hoc at any time, or you can schedule and export. So when you do either of this, it's going to back up everything in the management information tree for the model against which all the changes have been configured. It extracts a lot of objects out of the tree, and internally on the server, they are in a database. The database has what's called horizontal partitions. They're called shards, and it backs up all of the shards into separate files, compresses them into a tar gzip file. You will specify where you want to schedule the backup to some remote location. Specify, choose your protocol, secure copy, secure FTP, and of course, based on the protocol, you might need credentials, the device, the directory, and based on the protocol, you typically need credentials. Well, that shows you specify the remote destinations, and then finally you go ahead and specify the actual export policy. So now you can see after they've defined the remote destinations, they've specified the policy. Name the policy something, specify the format. You want to do it now or you want to schedule it, pick one of these remote destinations. One of these as the remote destination. You can also specify the target. That means you can say, well, I want a specific tenant, or I want the entire fabric, or I want only the infrastructure and management tenant. By default, if you don't specify the target, that's why it tells you it's optional. It basically backs up the entire configuration. Now, similarly, you may also choose to configure your imports. As and when you need to do the import, you're going to use the import option. Specify the remote location, protocol, hostname, IP address, PAP, username and password, and then you build your import policy. So policy could say, well, I just want to merge. Merge means just look at the things that are missing and only pull that information from the backup file into the current config. Okay. Now, you can say replace. Just replace the entire configuration. Don't do a merge, replace. Now there is, of course, the mode, best effort or atomic. Best effort mode, it ignores what is called database shards that cannot be imported. It just ignores any, not the whole shard, but any objects within the shard that cannot be imported. So it basically says, hey, if I cannot import a specific application profile, I'll just ignore the whole profile, or I cannot ignore the EPG, we'll just ignore that, but we'll ignore the rest of the EPGs. Okay, that's a best effort mode. I will only ignore the object. Atomic mode will say, well, I'll ignore the entire database shard. A shard in a database is more like one of the few rows of a table, or it's called horizontal partitions within the database. So a small error will ignore the entire shard. That's the atomic mode. You have the option to choose. It will ignore the shard and it will roll back with atomic. If there is a problem, it will say, sorry, I'm going to ignore and roll back to the original state. Any issues with a managed object within a shard? A shard is a database term, by the way. It's a horizontal partition inside a database. It's used for large database systems. You can actually choose to back them up in an encrypted manner, starting with 1.12. You do have the option to specify that you'd like these files to be encrypted. By the way, here is a APIC cluster. These are green, blue, and the peach color. They are depicting what is called database shards. And if you read a lot more on database technology, large database systems, Oracle, SQL, Sybase, Informic, they all support a technology called sharding. It is SHARD, and it is basically going to partition the database into different parts. So here it shows you every shard has 3 replicas. Every shard that is created, it has 3 replicas. And essentially, the replicas spread across these 3 servers in the cluster. If you had 5 servers, it will not make 5 replicas. This is a little misleading. If you have 7 servers in the cluster, it will not make 7 replicas. It still creates only 3. And then the point of having the green shard. So let's say server A, B, and C. This would be the master for the green shard probably. That means it is responsible for any changes in the database entries that belong to the shard. This could be the master for the blue shard. This could be the master for the peach shard. They actually have a hashing mechanism which decides on which of the servers these shards should be spread. Okay. Number of servers in a cluster is always maintained at odd, 3, 5, 7, 9, 11. Never an even count. Of course, you are asked the size of the cluster during Bootstrap, and you cannot randomly just add another fourth server. If you set it as 3, you'll have to actually expand the size. There is an option to expand the cluster size. Okay, as long as it's within the boundaries set by Cisco's particular version, you can expand, you can add, but you'll be adding them sequentially. So if I had 3 and then I want to expand it, I would make it 5. So I would add, after 3, the next server that gets added would be the APIC 4, and then the next one would be the 5th one. Similarly, I can reduce the size of the cluster. When I'm doing a reduction, I would be reducing in a reverse manner, which means you would remove cluster or APIC server 5, then you remove APIC server 4 if you want to go ahead and reduce it from a 5 to a 3. Okay. If you want to replace a server because its CPU utilization is too high, it's one of the old servers, you would have to decommission the APIC. You have an option within the ACI to go ahead and decommission the APIC. So it releases what's called the slot number. So if I had 1, 2, and 3, or A, B, and C are parts are numbered 1, 2, and 3 in the cluster, and I see this server is one of the older platforms, I want to decommission it, I would have to decommission this and then recommission a new server with the same number. ID would be 2. Okay. And if you're recommissioning APIC into an existing cluster, you've got to make sure that it's the same version as the ones on A and C, same APIC version. Starting from version 1.2, Cisco started supporting what's called a standby APIC. Okay, you actually have a question in the bootstraps and do you want to configure a standby? In fact, they allow 2 standby APICs. So they're called cold standbys. And this is usually recommended when you have a stretched fabric or you have what is called multiple pods in a ACI environment. That's when we recommend it. Next, we take a look at the management aspect. So you do know that we have a separate tenant for management that's called the management tenant. You can use in-band or out-of-band management. Right now, for the lab purposes, we are actually using out-of-band management, but you can actually enable both. And then you have a toggle switch inside the APIC where you can say which one becomes the default management mode. So you can toggle it as, hey, I want to make the out-of-band as the default, or I want to make the in-band as the default between the APIC server and whatever management device which is external to your ACI environment. So by default, your APICs, your leaf and spine switches, they all have a dedicated management port. Okay, and that's what is utilized for out-of-band management. So out-of-band means, of course, those management ports cannot be merged into your data plane or your forwarding plane. Okay. They are out-of-band management EPG will encompass the leaf and spine switches and the Cisco APICs that are part of the out-of-band management zone. Management services like NTP, syslog, they all tend to use out-of-band management network. And you can statically assign the out-of-band management IP, which is what I did. I actually did that through a command line on Monday. You can statically assign them. You can also dynamically, when you have a very large environment, you may not log in and configure each switch management IP manually. You can set a range, and then of course they can take an IP address from that range. Now, keep in mind the Out-of-band management is a separate entity. Hosts that are in your regular EPGs, they cannot communicate with the nodes in the out-of-band management. Any host that is considered a part of the external management instance profile, this particular EPG. So when you define this, you're going to define a range of subnets. The hosts that belong in this EPG can communicate using a contract. Okay, so notice they've very particularly said out-of-band contracts. So it's not a regular contract. These contracts are configured in the management tenant. You would use out-of-band contracts to allow any hosts that qualify in this EPG. They call the external management instance profile. So if I specify 10.2.0.0/16, that means any host with IPs 10.2xx can go ahead and communicate to the out-of-band management ports of the APIC by utilizing a contract. So you're going to have to build a out-of-band management contract or out-of-band contract. So essentially, what we are saying is the management ports on the supervisor where the modular switch, if you consider the word supervisor, it always brings into mind a modular switch, or the out-of-band port of a non-modular switch. They are accessible, they are exposed to this EPG as long as you have a contract. Now, these ports are, of course, 1 gig typically. Okay, so the bandwidth of the management port is much lower than your in-band data ports. Anytime you access, of course, you're subject to authentication, audit logging, any access through the out-of-band ports, authentication, privileges, or roles, and audit logging. The lab on Monday, I actually configured management IP statically, as I mentioned, but that's probably not scalable at all. So I would go ahead and say, you might want to go ahead and build a dynamic pool, and the switches can go ahead and grab an IP from that range. You can verify the IPs that are assigned to those switches. Multiple ways. You can log into the APIC and say show switch. You can log into the APIC, go into the management tenant. There's a section called node management addresses. And in there, you would have ideally created a policy with a range of addresses. So you can click the policy, it will show you which IP is assigned to which device. That's fairly simple. If you statically configured it, go to tenant management. And then, of course, under management addresses, you can find static node addresses. I had that verified on Monday. You can verify it in the GUI. You can verify it via the command line. In-band management allows management access or configuration changes can be done through your front panel data ports of your switches. It requires its own dedicated pool of addresses, and these pool of addresses should not be leaked outside the fabric. You can configure in-band management in two modes, layer 2 or layer 3. Well, let's look at the three types of EPGs that are accessing the in-band contract. You see, there's an in-band EPG, there's an in-band contract, application EPG. That would be an example of the web, the database, or the application EPG that you have created. So in a tenant application, that's an application EPG. It could be an EPG that is created because you have extended your ACI. ACI port is connected to another non-ACI switch, maybe a Catalyst or a Nexus or an IBM or an HP or any or an Arista, any non-ACI switch, and you configure what is called a layer 2 extension. That would be called a layer 2 bridged network. So those devices, so essentially, I have my leaf, and I connect this to, let's say, a Nexus 5K. Any hosts that are here, these would be the layer 2 bridged extension. Hosts A and B can also be used for managing the fabric, because I consider all of these as the layer 2 external EPG. Now, similarly, let's say I have a ISR or whatever router here. It's a layer 3 and a routing protocol. This is a routed connection, exchanging routing updates. Anything, any updates, any devices which are past, past the ISR router or your 7K, whatever the routing devices, we consider them layer 3 external EPGs. We will be discussing those two aspects, layer 2 and layer 3, in a later chapter. So this, you can have hosts in the layer 3 external also communicate to your in-band EPG. That's what it's actually showing you. You can configure it in two modes, layer 2 or in layer 3. Regardless. Okay, so if you're going to go ahead and use in-band, the encapsulation VLAN that is used for the in-band EPG is used to create a sub-interface on your APIC. Okay, you've got to do that. Remember, the in-band EPG is used not only on, or the in-band management is used not only on your switches, we're also going to go ahead and have in-band management of the APIC. So you've got to go ahead and configure some interface on the APIC, okay, which has this particular VLAN encapsulation configured for the in-band EPG. And on the leaf and spine switches, you'd have to create in-band interfaces. You can do it through the command line. Of course, the other way would be your GUI. Now, the other discussion is about additional management protocols. By default, CDP is disabled. So if you look at the CDP policy, on the access ports, CDP is disabled. There might be a time when you need to enable CDP purely because it's connecting to a device where, a Cisco device where you would want a CDP to be enabled. And the best practice is to go ahead and create, like we had you do it in, I think it was in lab 6, we had you create 2 policies, one called CDP enabled, one called CDP disabled. So you can use these 2 whenever you need it. Apply it to whichever policy groups. LLDP. LLDP is needed for Fabric discovery. So it goes without saying that by default, LLDP is enabled on Fabric. Okay. So sometimes you might need to disable LLDP. An instance would be when you're connecting your UCS blade server. That means UCS FIs to the leaf switch, you would need to disable LLDP. So again, Cisco recommends that you create 2 policies, one with LLDP enabled, one with LLDP disabled. So you can go ahead and use them in policy groups later on. NTP, because keeping time consistent is very important. You want to make sure your different logs, your monitoring, your operational activities have the right time. If ever the time difference between an APIC and the switch it services is greater than 7 hours, the encrypted communication channel, which is intra-fabric messaging, IFM, between the APIC and the switch will be toned down. It'll isolate the switch. So you'll have to make sure that you get the time synced correctly. We did see a configuration of how I did NTP configuration. You would do that under date and time policy. And that will be based on, are we using in-band or out-of-band management for the Fabric. When you're using out-of-band, especially when you use out-of-band, you can always configure your NTP as reachable through the out-of-band management plane. And if you're using in-band, you need to create a policy so that your switches can communicate to the NTP server. DNS, of course, is definitely a good thing. We saw there's an option to configure the DNS domain and also configure a default domain name. Always useful to have DNS. You can integrate with any third-party or VMM domain using their host name rather than their IP addresses. Next, we talk about the programmability aspect. So, sole point of configuration is the APIC. You cannot make changes to any spine or leaf switch by directly connecting to it. I'll actually just do 2 spines and 4 leaves. Makes more sense to do that. You can never directly connect to it. So if you really want to go ahead and make some changes, you're always going to connect to the APIC. The APIC exposes, the word is northbound. REST API. So as of today, most of us have been doing the configurations with a GUI. Now, if you even interact with it using your command line, it's still speaking via the REST API. In fact, you have a what they call, does everybody know what an API is? Anybody who's not familiar with this term or doesn't have a clear understanding of this term, please let me know. Stands for Application Programming Interface, but if you're not very clear, it usually makes more sense to a programmer, but if you're not very clear, please let me know. Nowadays, this term is thrown around quite a bit. So if you're not familiar with it, let me know. A quick summary. A quick summary of the API. Let's see, I'll use an analogy. Simple words, an API is a means for communication between two different applications. A conduit, sorry, for communication between two different applications. Let's make it simpler. You go to a restaurant. You place an order. And food is actually made in the kitchen by the chef or the sous chef and many others together. What's the conduit for communication between you as a customer and the chef in the kitchen? How is information relayed between you, the customer, and the chef in the kitchen? The waiter or the waitress. Thank you. Well, the waiter or the waitress is the API. The application programming interface. It is the API. The waiter or the waitress is the API. How many of you have seen websites where it doesn't ask you to create an account? It says use your Facebook login or use your Google login. And if you've seen those websites, okay. Use your Facebook login, use your Google login, and now we hear that they're going to say use your Apple login also. Remember, Apple is also getting into this game. Okay. So there's so many reasons behind that. So suppose I actually have an account on Dropbox. Yeah. Now keep in mind, when I go to this website, it asks me, I go to this website, it asks me saying you can use your Google login. So essentially, if I was logging in here, with my Gmail account, of course, these servers cannot authenticate me. So they send it through an authentication API to Google. Okay, so I send my credentials here on their website. It sends it, conduit for communication. That's an authentication API. Google checks the validity, gives the response. And of course, I'm permitted to use my files and my folders on Dropbox. So that is an example of an authentication API that is exposed by Google. So other vendors can use their services. It helps Google. How? Why does Google even offer this service? Or why does Facebook offer this service? Or why does Apple thinking about jumping into this now? What's the point? It helps them identify all the additional applications customers are actually interested in. Okay? It's actually more, it's not meant to help us. It's not meant to help us have one single sign-on. Do you think Google and Facebook were all thinking, oh, we'll just make one fine day, we'll just make it easier for all these billions of people around on the planet? No, exactly. It is true. They know what type of applications, what we're interested in, or what websites we're visiting and what we're interested in. So they're collecting this for statistics purposes. Hey, tomorrow they might just go, they say too many people logging into Dropbox. Google might say, hey, I think we're going to buy Dropbox. We're going to acquire this. So it's definitely not meant for making our lives easier. It does make it easier, but that's not the entire intent. So coming back to the APIC, it exposes an API which is termed the REST API. REST is well-known API. That means a lot of programmers know how to write applications that can interact with REST. It's an IETF defined. It's a well-known standard. VMware, Google, Facebook, Microsoft, Amazon, pretty much everybody supports REST. If I was a developer for Microsoft and I join as a developer for Cisco, I could very well improve the GUI interface provided for the APIC because it interacts with the REST API. So there we take a look at the programmable aspects. Well, we've always known networks are built with a bundle of or several hardware managed through command line, and they could not support next generation data centers. What they mean by that is it was not. Here's the thing, when server people started automating things, okay? So if you tell a server person to roll out server for installing Oracle, in a matter of a minute or two, they would have your virtual machine ready. They probably don't need to acquire a whole new physical server and install an operating system. Even if that were, they would have automated this thing so quickly that in a matter of 5 or 10 minutes, you would have a server ready. But if you tell a network person, hey, we're going to add these servers, the network person will be running helter-skelter. Oh, I have to log into these 10 switches, enable the VLAN, make sure this VLAN is trunking across, and So even if it is a copy and paste, we're going to paste it into 10 switches. And so it takes a lot more time from a network perspective to meet the demands of the business. They've always said the network is the laggard, which means the network causes the latency in business development. Server people have really automated things and made life a lot easier. So it is undoubtedly there was a need for programmability. Should be able to double click a file and then it should be able to apply the settings on 10 or 20 or 30 switches simultaneously, make changes to 40 routers or 100 firewalls by double clicking one file. Okay. So that's why programmability has become very, very important. Businesses need dynamic changes done quickly. Environments we have currently today in the network, there are physical servers, there are virtualized loads, there are containers. The traditional approach, not effective anymore. So also keep in mind, rather than typing in the command line on the APIC, if you notice, we're just being more abstract. We're going through the GUI and configuring, hey, I want this application, these are the 3 tiers, this one should talk to this one. We're not actually typing in the access list details. So we have taken a different approach, which is more declarative. It enforces the application's requirements in the fabric. Okay. So we have built-in programmability. I did mention that the entire fabric is considered as a single virtual system. Okay. And at the switch level, so Nexus 9K, there are 2 different operating systems. One is, of course, the regular NXOS. And the one that we use for ACI is the object-oriented operating system. So if you think about it, even at the device level, they've kind of changed the operating system to be more an object-oriented one. Why? Because the APIC has a tree and everything falls within this tree as a managed object. So you're basically within a GUI configuring an interface 1/5 on leaf 3. This managed object has its own distinguished name. So when you're in the GUI and you're clicking submit or OK, it's saving against this tree. And this object has a name, which it then conveys to the right Nexus switch, which also has the object-oriented model. So it accepts the change for the object, which is then converted into command line. Okay. The provides a lot of benefits, programmability, easier provisioning of large configurations. So let's take a look. REST API. Whether you use the GUI, run a Python script, post some XML files, or you use the command line on the APIC, it's always saving changes against an object model. This is termed industry-wide, that is known as a modeling language. There's a term in the industry called modeling language, and there are several modeling languages out there. Cisco proprietary one, it's called the Management Information Tree or Management Information Model. Every possible configuration object in the GUI or in the command line, it's represented in this model. Every port on your leaf switch, somewhere in the model. Every port property, CDP, LLDP, LACP, VLAN, configuration, speeds, duplex, MTU, all of those are somewhere in the model. Okay. So this is the physical switch, the collection of switches. So when you're making a change, it's saving the logical model, which conveys it in Cisco ACI environment. It's conveyed using OpFlex. The concrete model, the actual model relies, or it's there, not relies, it's there in these switches. It applies to those switches, which then render it in command line. Now, can I have through the REST API. In fact, I would say GUI, the girls REST API command line, Python script, other REST clients, third-party products, some cloud orchestrator platforms which use REST. Even so, we saw two products yesterday which use REST. OpenStack, which communicates using REST. Also, we saw Microsoft's Azure PAC and their SDVMM communicates using REST through the APIC. Okay. So this is the management information tree. Notice how everything, physical as well as logical, right? They haven't shown you logical like VLANs and VRFs and tenant names and so on. Every object has its own object name. In this modeling language, the names are called distinguished name. Okay. Distinguished name. It makes that object will have a unique ID. The managed object has a unique ID. They're called distinguished names. In SNMP, the modeling language is called SMI. That's SNMP. And the unique IDs are called the object IDs. Anyone knows how object IDs are represented in SNMP? Ever seen object IDs? Yes, thank you, Victor. They are numbers. They're numeric numbers represented or separated by the dot. There will be dot 1, dot 9, dot 5, dot 4, dot 3, dot. We'll keep going down the tree based on where that object lies. In this SNMP tree called SMI. Okay. So you can do queries. You can say, show me all chassis. Oh, show me all ports. Or show me a chassis 1, card 1, port 1. That means I'm saying, show me a particular object. Okay. You can actually say, show me the entire tree. Start with the root. So a distinguished name would be an example. I would say a distinguished name would be more like this. It would say, well, in the topology, let's say we have pods. We have a pod 1. Within the pod 1, I have a node 105. And on that system, the physical interface, which is Ethernet 1/5 or something. This entire thing would be called a distinguished name, an example of a distinguished name. It just identifies that object uniquely in that tree. So here is an example of an object. The object has properties that define the object, and they are classified in this example. It actually shows you that the process called DME, Data Management Engine, is the one which allows configurational properties. like setting the description for the port, administrative state of the port. That's the process. Data management engine. Okay. The one which shows you everything other than spanning tree, for example, operational output, it's the process called port manager. Okay. And the one which shows you the status of spanning tree, it's actually the spanning tree process, showing you the color blocking logic. That means show me the state of spanning tree, whether it's in forwarding state or in blocking state. It's called CBL, color blocking logic. That's not only a Cisco ACI terminology, you may even see it in debugs on some hardware platforms when spanning tree is running. So it is an open industry standard that's showing you northbound. You may use REST API. It enables it to support a vast variety of products. They call it a very rich ecosystem. Okay. You have DevOps libraries. These are called Chef or Puppet or Ansible. Products which enable configuration changes use these DevOps libraries. There's a Python SDK, software development kit called Cobra. Cisco's got an orchestration framework product called Cisco Cloud something. So you have VMware has an orchestration product, vRealize, system management product from HP. IBM has enterprise monitoring products which communicate. VMware has their what is it? Their vCenter and hypervisor management product, or you have the Microsoft SCVMM. And then, of course, we have a lot of third-party automation products that all speak through the REST API. Okay, and then they would send instructions to the REST API, and that's written into the APIC, and the APIC conveys it to the 9K switches, or even to what is layer 4 to layer 7 device. What do you think they mean by layer 4 to layer 7? Okay, Greg has had Ginger, your messages are showing up a little. Okay, just Greg is firewall, load balancer, and similar. Shayla said load balancers. Ginger said optimizers, and then you said firewalls. Okay, so I would say any device which can only function if it can read into the packets layer 4 through layer 7 values. Only then we classify it as layer 4 to layer 7, like firewalls, load balancers, web application firewalls, IPS, IDS, okay. Any application delivery controllers, general ADCs, they would all be classified as layer 4 to layer 7 devices. So APIC speaks to the 9K switches using OpFlex. And then to these southbound devices, we can go ahead and communicate as long as the vendor provides us with some kind of device package. Device package file. What that does is it typically has at least two files in there. One is a XML file, which gives the model of, let's say this is a load balancer. All of its properties should be part of the tree, should be incorporated into this tree. So there's a file like that, it's an XML file. And then there is, of course, a Python file, which enables any changes that are sent to the APIC to be converted into the required command line or the configuration of the load balancer. So that's how it speaks to the third-party vendor devices. Of course, the one place that you would go for all development resources from an ACI perspective, it's centralized on Cisco DevNet, a single central repository. You can find yourself, you can sign up for Sandbox. You have learning material for programmability basics. You have information about the APIs. You have a lot of tools that you can download. And then if you go to GitHub, okay, GitHub is where you would find a lot of scripts and libraries that are available for ACI. So that's why it shows you this portal would make another very handy location for programmability deep dive. So what is REST? It's actually an industry standard architectural style. It is something that is based off HTTP. So in HTTP, we have HTTP client. Oops. And it connects to an HTTP server. I kind of like to pretend as if REST is a HTTP subsystem kind of thing, because you cannot have REST unless you have HTTP. So similarly, there's a REST client. So you actually use a URL here, and then it always has some HTTP methods like post or get or something. REST client speaks to a REST API or a REST server, and it uses URL and HTTP methods. Okay, consists of clients and servers. Clients initiate the request. Now here, typically, the back and forth is HTML. In a REST client, the back and forth interaction is actually in a language called JSON or XML. Okay, that's why it says. So there is a API that you enable. It's called RESTful API. Uses HTTP and REST principles. HTTP uses methods like get, put, post, delete. Get is equivalent to show commands. Post is to add something new loop back interface or something. You want to change, you would do put, delete. These are all, these plus many more are HTTP methods. So that's why I like to call REST as a HTTP subsystem. REST cannot exist without HTTP because it uses HTTP methods and HTTP responses. Anybody seen this error? 404 on the browser anytime? Ever seen 400, 404? Common, right? Now these are HTTP error codes. 400, for example, is when you have authentication fails, you will get a 400 error. 404 could be a URL issue. So HTTP has its own generic response codes, and REST uses the very same response codes. In other words, REST cannot exist unless HTTP is enabled. This one shows you that I kind of said typically between an HTTP client and an HTTP server. So analogy, HTTP client, HTTP server. You'd probably send a URL request, maybe a GET, and then you get your HTML responses. If you have a REST client and you specify the GET and you specify the URL, and that's the REST API or REST server. Responses are JSON or XML. Now this is a GET request, so you basically don't provide any values, you just specify the URL and then you get your responses. But of course, if you want to create an interface, you would be using something like a post. Or you want to provide your user ID and password for login purposes, you would be using a post, and then you'd have to specify the username and password. Now, REST accepts REST API would accept input of XML So this one's an example of XML. Just generic XML. It doesn't really have anything to do with the APIC, okay? They're just showing you the format of XML. XML as in itself was developed, actually I should say standardized by the World Wide Web Council, W3C. It's usually used to transport data or even to store data. You need some software to display it. So you either need a browser, HTML, it has to piggyback, or you need some application. Stored in plain text, it's more verbose, more detailed. This is a simpler language. Among the two, this is older, more flexible, simpler, easier to learn. That's example showing you XML. There's a start tag, an end tag. Similarly, a child tag with its own end tag, another child tag, its own end tag, another child tag with its own end tag. And you can see it is in plain text, which means XML can be used in, it's really platform independent. Now, similarly, there's another language that is supported by REST. It's called JSON, JavaScript Object Language. It's more simpler and compact. It always has what they call a key or a name and a value. It's identified by as known as key value pair. Okay. So this is usually a little bit more easier to deal with once you start programming compared to the XML language. So when you use a REST client, you're going to have to specify the URL, and the URL is typically HTTP or S. Of course, it can be HTTPS, hostname or IP, optional, port number, the word API, and then either your targeting, that means your URL would be to modify an existing object or create a new object. So it would be the word MO followed by a distinguished name. Or you might say, show me all VLANs. That means it would be the word class followed by VLAN as the class. Okay. And you would give it a dot, JSON, because you're typing in the URL in the REST client, you're saying get HTTP server name, blah, blah, dot JSON. That means your response will be in JSON. And if I go ahead and say dot XML, the response will be in XML. Okay. You can always follow this. You can say, show me all interface, but only show me which has speed of 10 gig. So you can use a filter. Okay. All of this is part of the filter, starting from the question mark onwards. You have seen that there were methods they showed here as get. Get is show, so it's not doing any modifications. Post, put, and delete. These are doing some form of modification. So the outcome, REST API, does allow you to read, that means retrieve, as well as perform write operations and use filters. And sometimes it's not easy to arrive at the distinguished name. How do you know what's the distinguished name of an object? Well, you can use the object browser. How many of you have used a MIB browser in SNMP? Why do you have? Okay. Greg, you've also used one. Okay. Lets you walk the SNMP tree. That's what the MIB browser does. Now remember, I said there are several modeling languages out there. SNMP has its own modeling language, which is industry standard. SNMP is an industry standard protocol, not proprietary. It's called SMI. If you want to go ahead and walk through this tree and see what objects, which is the parent, which is the tile, something called the MIB browser. If you want to walk through Cisco's management information tree, they have a utility called that's how you get to that utility. Log in, provide your credentials. Without specifying anything, you just run the query. It shows you the top level objects. Now notice there's a less than and greater than symbol. There's the distinguished name of an object. And it shows me the node number, by the way, is 101, shows the distinguished name. Less than and greater than. Less than means take me back to the parent. Show me child objects. The greater than is show child of node 101. That means within the tree, any branches that fall under 101 is what we're going to look at. Okay, so you can actually go through this. It'll show you if there are 5 objects below that node. It'll show you those. Each one of them, you can see the distinguished name. That's an object browser. Anyone done PowerShell programming? PowerShell is Microsoft. I don't want to say it is full-fledged programming. Actually, it's a lot easier. It's a command. They call it command-led. The command line utilities, which let you go ahead and automate a lot of tasks natively in Microsoft. So in the past, like if I had to add, say, 40 usernames into Active Directory. This is before they came out with PowerShell. 40 usernames into Active Directory. Either I would do that manually or probably try some form of imports. Okay. In 2006 or 2007, Microsoft announced these PowerShell programming capability. So what the server admin can do is code into these commandlets. Commandlets are more like command lines. So you make use of the command line help once these commandlets are there. And then you can code them into your into a script file, and then double click the file and we'll go ahead and add your 40 names into the Active Directory server. Microsoft has, after they started providing PowerShell as an option, pretty much all Microsoft features. If you want to configure database tables, data stores, anything, add Exchange mailboxes, you can automate all of that using PowerShell commandlets. Okay, so for ease of configuring the APIC, they also, Cisco provides what's called the ACI Power Tool. I believe there is a little bit more than 1,500 commandlets, which lets you automate pretty much everything in ACI, adding tenants, adding bridge domains, adding application profiles, EPGs, contracts. All of these can be done. They have the basic 4, get, add, set, and remove, and for the different types of objects. Okay, get, add, set, and remove. That's basically what they have. Okay. So these are just showing you, like, I want to get the list of all tenants. I want to enable, this is, by the way, HTTPS is enabled, but HTTP is not, so I'm going to enable it. I can do that. The disable, that's a set again. They're getting it, and then they're setting it, the administrative state of HTTP communication. You can see how they're disabling it. Okay. That's Power Tools. You can put it all together in one file. Now, another one that is quite interesting, it's actually, I would say, like a gift to the developer. This is a utility inside the GUI. It's called API Inspector, and I'm going to tell you what it does. We'll see it displayed later on. I'll be discussing it later. Suppose I have my GUI open here. This is the GUI. And then I click on Show API Inspector. It'll open up another window. Okay, now if I'm in the GUI, I go ahead and add a bridge domain. It will show me the corresponding, the post as the method, because I'm adding a new bridge domain. It will show the URL for the bridge domain. And it'll show me how this information is sent in JSON. Okay, what you can do is you can actually capture all of this, copy it out of the API Inspector, To make life easier for you, when you switch to programming, you can actually go ahead and put all of this into a Python script later. A little bit changes in Python, but you can automate it. So essentially, that's what it gives you, a real-time display. If I click on the All Tenants button in the GUI, say once I add, I click Finish, and I click on All Tenants, it would immediately do get, and then the class called tenant. The URL will show me FV tenant is the class, and shows me the, so I can copy this and put it into a script, which I can double click the next time around. So any interaction by the GUI or the command line, or any interaction via the REST API, if it's a third-party application sending something, all of this can be observed by the API inspector. It'll show you the corresponding JSON and the URL. Now, REST is an industry standard API. So there are several REST clients out there. Okay, there's a long list of REST clients. The Firefox has one, it's called Firefox REST. Google has one, which is of course called Postman, the one that you see right now. There's, I can't remember the company that developed it, it's called REST Easy. This list goes on. There are several REST clients out there. You have a built-in client in the Linux. Linux has a command line REST client. It's called CURL, curl, command line URL. This is actually plugin for Chrome, downloaded from your Google Store. And now you can actually run it independent of Chrome. Provides easy GUI to interact with your REST API. So this is where you choose your HTTP methods. That's where you type in your URL and then you click the send. If all you want to do is a show command. Okay. If you want to make a change, you would pick post here. You would type in your URL. And when you do post, so when you click on post here, there's a tab here called body. It becomes active. So you can type in your, suppose you want to create a new loopback interface. You will be typing in the loopback number, the IP address, subnet mask, and other fields in the body. So that's another very nice utility to interact with REST. Okay. Another open source developed utility, that's called the ACI Toolkit. It has some applications, actually several. Some common ones are shown here. One is called Endpoint Tracker. ACI Toolkit is not Cisco developed. It's an open source one. And the toolkit, which is, it has applications that enables you to create tenants and create application profiles and EPGs and contracts and associate them to your physical infrastructure. The two that they have mentioned here, by the way, this is found, you can download it off of GitHub. GitHub.com, under Data Center, there's an option called Toolkit, ACI Toolkit. Now, two applications, one of them is the Endpoint Tracker. Endpoint Tracker, what it does is it connects to your APIC database, connects to the APIC, pulls out information about all the endpoints. Remember, I mentioned the local station table and the global station table. So what this one would do is goes ahead and reads information about the endpoints that have been detected in the ACI network, and it classifies them into their EPGs. What it would do is connects to it, pulls out information into a MySQL database, pulls out all the endpoint information, populates the MySQL database, and then, of course, the application will display the endpoint information and which EPG the endpoint belongs to. So there's two parts to endpoint tracker. One is to connect to the APIC and populate your SQL database. Sorry. The second is, of course, to go ahead and generate this GUI. So this is actually an output of the GUI. The endpoint tracker GUI is showing you the tenant name, the application, the EPG, MAC addresses that were detected. Another utility in the ACI toolkit, it's called the lint. Traditionally, lint is something we've used with programming language C. C linting would mean we're telling this linter tool to check if everything is configured correctly. Okay. In ACI linting, I would be telling it, so if I had a Python script where I've actually, in the script, I'm creating a tenant or VRF and a bridge domain. Now, what you have to do is, these are three independent commands within the script, which creates the tenant. If I don't associate the VRF with the tenant's name, so every time you create a VRF, you're going to specify in which tenant. Makes sense, because if you look at the GUI, you're going inside a tenant to create a VRF. Now, if I were to type a Python command to create a VRF, but I don't specify the tenant name, when I lint this file with ACI lint, it will tell me that the VRF doesn't know which tenant it's to be associated with. It'll raise that error. So that's why it raises, checks, and notifies any misconfiguration errors. Could be due to security issues, or it could be due to configuration issues. Okay. And the last is for discussion right now is a software development kit called Cobra. Okay. So I'll just make it easy what that means. Here's my REST API. And it's on the APIC. If you had to write a Python script about get VLAN, well, essentially within the script, you'd have to say get followed by a URL. You got to know the URL. Okay, so that's how you would do it. Whereas if I had the software development kit called Cobra, my Python script would just say get VLAN. It doesn't have to say get followed by the URL. That's what it tells you, provides the native bindings. So essentially, my Python script would say get VLAN, and the software development kit will convert it into the required URL. Okay. Okay. Cobra provides the methods that match the REST methods used by the GUI. Okay. Now, what you could do is if you capture any policy that is created in the GUI, what you can do is go to the GUI, right-click an object. So when you say you have a tenant called tenant 10, and you have already configured inside the tenant, the VRF. Now I'll just call this tenant production. You've already configured your VRF for production, your bridge domains, your applications, your profiles. This tenant is completely configured. Now I want a similar tenant for dev test. Okay, I could right-click on this, save the settings as a XML, and then I can generate a Python script, which would essentially be using Cobra. So once I generate that Python script, next time around, I want to create another tenant for, say, DMZ. I can just edit that. That's why it says you can go ahead and create a programming template using the settings that you created in the GUI. There it shows you Cobra is installed on the APIC as egg files. Of course, this is Linux, so it's using easy install to give you the instructions to install the Cobra. There it shows you. I'm not giving any URLs in here, how I would go about creating or importing or searching for a particular object. No URLs. The Cobra software development kit has its own documentation. It basically, or if you're a programmer, you can search for the help of the SDK. It shows you that if you're to create a tenant, you just go ahead and say tenant and the tenant name, and it's done in the root, the universe. Okay, I'm going to look up the top level, which is the universe. Look up by the distinguished name. You can name it anything, by the way. These names can be anything. So that's what SDK is. And this is showing you that if you captured an XML or a JSON, so I mentioned what you can do. You can right-click on any tenant, existing production tenant you want to mimic or imitate the same thing as your dev test. Right-click on the existing tenant. You can save as, allows you to save as XML or JSON. Once you have this saved in XML or JSON, you can generate a Python script from it because Cisco has provided us with a tool. It's actually not Cisco, it's a third-party developed, again, open source, ARIA. ARIA.py, it's actually third-party developed. It stands for APIC REST to Python Adapter. That's what it stands for, APIC REST to Python Adapter. So take any XML or JSON, and that's actually showing us JSON. Maybe you right-click and you say save as, and you save it in JSON. Run it through ARIA, which is a command line utility. And that will generate your Python code, example. And you might see it's using Cobra, the software development kit. Next time around, I want to create a tenant. I'm just going to go ahead and edit the name of the VRF, the name of the bridge domain, a MAC address, edit. I can just edit this file, save it as something else, and run it next time around. Okay, I'm going to go through this aspect a little bit more quickly because it is an orchestration product, which means it is product that is higher up in the level, above the APIC. Remember, APIC is purely for network orchestration, but Cisco Cloud Center, it is allows deployment of applications in multiple data centers, be it a private cloud or public cloud. What do I mean by that? If you look at Cisco Cloud Center, notice all the different cloud platforms it supports: public cloud, private cloud, okay, and even an enterprise data center. So you can actually have your applications deployed across all of these environments. And it ensures that ACI would go ahead and implement your network policy and configure these fabric switches based on the applications requirements. So you can actually transparently integrate the Cloud Center with ACI. And it shows you the integration would achieve this. Users can go ahead and utilize the self-service on-demand deployment in Cloud Center. Now we'll go ahead and leverage the ACI's network policy and configure the switches accordingly. Then, from a security perspective, in Cloud Center, you just need to click and specify the security needed. And in the background, it will make Cisco ACI do the micro-segmentation that you might need in order to implement the security that you configure in your Cloud Center application requirement. And then, of course, it shows you, it automates the entire stack. The entire application deployment is completely automated in Cloud Center. And of course, that will translate directly into the ACI application profile, the EPGs, and the required contracts between those EPGs. That shows you multiple benefits of integration. Agility would simply mean it's going to be a lot faster and seamless. We also saw security being a benefit, avails of the micro-segmentation without having to write any long code to arrive at security. And of course, it's a lot more efficient from a performance perspective. It improves performance purely because your network is deployed based on the application's priority. And then finally, the integration is very transparent without any additional plugins to be installed. There shows you, it actually speaks through the REST API, the same thing. That's the northbound API exposed by the APIC. And of course, Cloud Center integrates into it through the REST API. You can see the support of Cloud Center, broad range of public and private clouds, as well as, of course, your enterprise data center solutions. If you have UCS Director or vCenter, it can all integrate into the Cloud Center environment. You can use it for several purposes. Here's a use case being shown. You want to go ahead and deploy a multi-tier application without knowing any programming or without knowledge of the details of your network configuration. That's the screen on the Cloud Center. You can see it, and they've actually done it with a few clicks, the application requirements. And of course, this is a screen, old GUI output of how the application gets deployed in the APIC. They've actually deployed it more like a 3-tier application there. You may also use it for a stretched application. Specific sites have specific components of the application. And you can achieve a lot using Cloud Center because it will reduce your cost, because Cloud Center can actually charge based on use. And will make sure that you have the highest security needed by using the microsegmentation. And of course, Cloud Center actually ensures that you have met compliance for environments like your private cloud or your enterprise data center. When you do have a stretched application, you would select in the Cloud Center, it will ask you for your mode of deployment. You're going to select hybrid, and it'll show you the options to choose your separate clouds over which the application is deployed. It will support ACI deployments which are stretched. It will support ACI deployments which have multiple pods, PODs. You've not seen that as yet. Stretched means your switches are stretched across 2 different sites or 3 different sites. That's what a stretched fabric is. Or it could be multiple pods, or of course, it could be multiple clouds. The application could be deployed or stretched across multiple clouds. So some component could be in ACI, maybe your web server and your app server are in the ACI cloud or in the ACI Fabric, and then your database server could be in AWS, could be in your AWS, which would be a public cloud for all you know. Okay, so you can use it even for that purpose. It's actually quite easy. It shows you what it's doing. And last use case is if you want to migrate one of your existing applications from a public cloud to ACI, you can actually go ahead and migrate it. So migration is also done through the Cloud Center. There's a feature called Migrate, which allows you to migrate applications from, I can even do this, migrate an application which is in the public cloud of Dimension Data or Rackspace into the private cloud of WAP or UCS Director or vSphere. So migration is achieved very easily through this orchestration application called Cloud Center. Now, I must tell you the reason for this section to be included here is purely because the Cloud Center marketing team decided to introduce these slides into this chapter, trying to convince you that if you have ACI, this might be a good orchestration product to consider. Sorry. The diagrams are wrong. They don't fit here. I'm going to go ahead and talk about these diagrams later. The App Center. You actually can download apps for the ACI APIC, or you can even go ahead and these are hosted and shared at the App Center. It's aciappcenter.cisco.com. If you can read it, that's where it is, aciappcenter.cisco.com. You can also go ahead and develop and upload, okay, your own ACI app. So typically you would be browsing the App Center and you would have description of the particular apps and you can download it. It basically just gives you quite a lot of options to download. As you can see, there are a few. You can actually look at it through your apps menu, and you can look at what apps you may have installed. There's an option called Install Apps. 2 types of applications. We have stateless apps And stateful apps. Stateless apps would be simple or cascading style sheet, CSS or JavaScript. Front-end apps that would run within the APIC GUI as if it's a part of the APIC GUI. Okay, these are front-end apps only. You don't see, this would be an example of a stateless app. Okay, they are going to run within the GUI as if it's a part of the GUI. Okay. So when you click the application to launch it, the GUI will launch the application in an iframe. That's actually showing you the GUI making a request to the APIC server for a token. Based on whoever you logged into the GUI, it's using the same authentication and asking the REST APIC server for a token. And then, of course, you can see the token response. Of course, this is showing you that it's received. These two are part of the APIC. Actually, I don't know if you can identify. This is the DME. It's also part of the APIC. This is the REST API, part of the APIC. And this is the GUI interface. It's all part of the APIC. Though you see it as three different entities, they're all, you're going to browse to the GUI. You're going to be logging in first, and then you click on the app. Okay. And using the same credentials, there's a request being sent to the APIC server, okay, for a token. And you can see the token is received. And then, of course, the application that's kind of saying, hey, using the same single sign-on, we want to use the app. So it responds back saying, hey, that application, that sign-on is valid. So here's your token. And now any future interaction with the app is done using the token. That's a stateless application. A stateful application has a backend service that continuously runs. By the way, this is your backend service, for example. It's actually running in a container, as you can see. Okay. They store the state information, that's why it's called stateful, in this backend for specific reasons. In this example, it shows you a Docker container, which again communicates with the APIC using the REST API. The only difference is, of course, token request. If it wasn't a backend, it stores that request in the Docker. Okay. And of course, you would see the response being sent back. So there'd be kind of like a key given for accessing this application's container when the token is just sent back. The last topic in this chapter would be ACI upgrade and image management. So you've seen, there's the APIC, oops. And you have your spine switches, your leaf switches. Anybody here who has more than one fabric, by the way? More than one fabric. And I call it a multi-site solution. Okay, anybody here who has multiple pods, PODs? You're doing multi-site. Okay, so that means you have multiple fabrics probably. Not multiple physical sites. You're doing multi-site controller. I'm talking about multiple fabrics. I'm not talking about multiple physical sites. There's a keyword in ACI called the multi-site controller for multiple fabrics. Okay, Greg has multiple pods and Boyd will be going multiple pods. We'll be discussing those deployments later. There is a chapter for the fabric extension. So all this while, we haven't mentioned that because it's not part of this discussion right now, but the deployment, it doesn't have to be the now, Ginger, replacing your OTV does not necessarily mean that it's going to be multi-site from an ACI perspective. Cisco ACI physical sites could be multiple, but you might be using what's called PODs pods. Only when you have multiple ACI fabrics, that means multiple clusters, multiple sets of spines, independent clusters themselves, and then you connect them with another product called multi-site controller. That would be a multi-site solution. The keyword, I'm going to put that word multi-site for ACI, not meaning physical sites. So image upgrade and management. We know that there are some images here. That's the APIC software. We have images on these. So we have the switch from there. That takes care of these. What is catalog from there? Anyone heard the term catalog? Well, the catalog is basically the one which tells the APIC what type of switches, the model of switches, the versions of the software, the hardware, the diagnostic utilities available for these pieces of hardware. So typically, the catalog, usually, catalog is part of the APICs. The APIC image. But once in a blue moon, so usually bundled with the APIC controller's image, but once in a blue moon, they might not do an entire controller image upgrade. All you need to do is a catalog image. And that's what they mean by the three components that are the ones of types of images that you would come across for upgrade purposes. So software is always in this format, the major, the minor, and of course major dot minor, and of course in parentheses, a maintenance release, which typically represents any fixes for the bugs, okay, or any defects that they may have observed. Now, should they all be the same version? Yes, Ideally, all APICs should be running the same version. All Leaf and Spine switches should run the same operation or the same version during a production, in a production environment. The only time Cisco kind of tolerates you having disparate versions is during upgrades. But that shouldn't be like a solution which stays for 4 or 5 months. It's only during upgrades, which is shorter intervals of time. Your upgrade or maintenance window is when they would kind of even help you, support you, but if you keep it running for longer, they're not going to step in. So ideally, we should have consistent images or the same image on your APIC controllers, same image on your switches, and of course the same images. If you were doing the catalog separately, you've got to make sure that it's the same on the APIC controller. So firmware management. Let's go to firmware repository. It's a store that I would say is in the APIC, and then it pushes it from there to the switches. So we're going to go ahead and upload all our images into that repository, and then it is going to sync it with all the APICs in the cluster. Okay. Please do not confuse firmware here with component firmware. Now, why do they mention that? Because in up until 4, okay, APIC would run only on Cisco UCS. Cisco UCS has its different components. They call the RAID controller firmware, the BIOS image upgrade, the CIMC upgrade. Those are components of the UCS server. That's done differently. That's done through UCS or that's a different story. That's usually done through a UCS Fabric interconnect, or in this case, it's a C-series server. So you would usually do it through a UCS C-series upgrade. So don't confuse that. We're talking about APIC, which is the APIC software that runs over. Okay. So we are going to go ahead and configure. The first thing is to make sure that you have the images in the firmware repository. You have to download it from maybe a secure copy server or an HTTP server into the firmware repository, which is essentially on your APIC controllers. So you're going to find that there is the option to do that on the admin tab under firmware. Okay. There is, of course, you can see the option to, by the way, this is where you see the repository. That's where you go ahead and configure what you should download, from which server to download, which protocol to use. You could also, if you have, suppose I'm browsing from my PC and I have the firmware on my local PC, I can also do that. Upload it into this repository from the local PC. That's also an option. Okay. So that's where you can see the content of the repository. This is where you can download from an HTTP or a secure copy server, or upload from your local PC into the firmware repository. Then, what are these terms? The firmware groups and the group policy, maintenance group. Okay. A group of switches, this group is a group of switches where you're going to apply the same firmware group policy. So you're going to understand what is a firmware group policy. Similarly, there's a maintenance group on which you apply a maintenance group policy. So a group of switches on which you plan to jointly upgrade together, that would be a maintenance group. Okay. So I may choose to upgrade leaf 1, leaf 3, leaf 5 jointly. The reason I specify that is if you think about it, an adequate design in a network, an appropriate design. If I have leaf 1, leaf 2, leaf 3, leaf 4, leaf 5, and leaf 6. Now think about it, most of the time you may have some form of VPC, so be it a switch that I'm connecting to, okay, and so I'm going to probably choose to put this into a maintenance group, and maybe L2, L4, L6 in a different maintenance group. You see why? Because I always have redundant connections. I kind of group them based on how they are connected into what we call the maintenance group. Okay. You can go ahead and choose to upgrade right now, like on demand, or according to a schedule. That means you can defer your upgrade to some maintenance window later at night. Okay. So similarly, I would also do this. I would put my, if I have only 2 spines, if I had only 2 spines, I would go ahead and create one spine in one of the maintenance groups, the other spine in another maintenance group. So ideally, you should have at least 2 maintenance groups. Okay. So I might upgrade my maintenance group 1 first, and then after all those switches come back online, upgrade my second maintenance group. So I have policies. Policy would specify when and what. That's going to be the part of the policy. The firmware for the controller, which version should be applied. That would be something that I configure in the policy of the controller firmware. Of course, which catalog should be applied. And all of them can be applied on a scheduled basis. So right there under the firmware option, I find the controller firmware. Okay. And then once you choose that, under, for example, they've actually added, okay, by the way, there's the option here to create an controller firmware policy. Okay. So you can go ahead and create your policies right there. The policy is going to tell you to choose the schedule. Do you want to do it right now? Do you want to schedule it for later? Which firmware version? Do you want to ignore compatibility checks? And click the submit option. They do them in 1 by 1 in turn. So each APIC takes, I don't know, probably about 10 to 15 minutes to upgrade. Okay. So once it finishes the upgrade, it disconnects itself from the cluster, and of course, it will reboot with a new image. And then The next APIC would reboot, do the same thing. You pretty much should not make any changes until the cluster comes back to a fully fit state. That means all of the devices have converged and come back to a fully operational state. The switch image, another folder there, as you may see, node firmware. So this was controller firmware, that's node firmware. If you click on the Fabric node firmware, you can see how it's showing you the status currently, the models, and of course their names, node IDs, and the current firmware. And do you have anything scheduled, their current role, do they belong to a firmware group? Does a method exist to lock Fabric changes during upgrade? I would say yes and no. If you had only 3 in the cluster, and if you're making a change to a shard on that device or the right shard, it would, or the right replica, it would. But if you had 5 in the cluster, it doesn't actually tell you. So it's essentially up to you to go ahead and make sure you don't make changes. If you have anything more than 3 in the cluster, you would not be given a message saying, please don't make a change, or an upgrade is going on. Okay. So you can create a firmware group, give it a group name, specify which target version you want, select the node IDs in the firmware group, okay, and click submit. That's basically saying which version you want on that firmware group. And then maintenance groups, I mentioned you need at least 2, maybe all your even numbered nodes in one, and the other group should have all your odd numbered nodes. And make sure your spine switches are split into these groups in an even manner. That means if you have 6 spines, 3 in one, 3 in the other. 4 spines, 2 in one, 2 in the other. So in the maintenance group, you're going to specify the schedule, the option about should it pause on upgrade failure, which is the default mode, or do not pause on failure. And then, of course, it also asks you the schedule in the maintenance group. So we don't have a screenshot of the maintenance group, and that's something you configure in the maintenance group. Before you do the upgrade, there are some things. This is a pre-check step before you perform any upgrades, some guidelines. Clear any faults you may see. Okay. Make sure if you're using the APIC on the Cisco UCS, I'm using that word very specifically because Cisco started supporting it on other platforms. So ensure you have the required SIMC version. That would mean you've got to make sure the hardware has its Cisco Integrated Management Controller upgraded to a certain release in order to support the APIC upgrade. Make sure you have the images in your firmware repository. I'm going to upgrade the APICs first, see that the cluster is fully fit. Check the fabric, make sure you have no faults. The or clear your faults, put them into different maintenance groups, upgrade your first group, make sure it's come back operational, everything is back, and then upgrade the second group. If you're not sure about the, Cisco does publish for each APIC upgrade the required SIMC version. Not familiar with it? Ask your server admin to upgrade the SIMC. This is SIMC is a out-of-band management chipset inside all UCS servers. It stands for the Cisco Integrated Management Controller. It's kind of like HP has ILO and Dell has DRAC. They all have their own chipsets for out-of-band management. So you do need a certain release of SIMC in order to upgrade your APIC controller firmware. Well, of course, continuing on, make sure you create a backup before you do the upgrade. You have to have the Fabric admin role, your permissions. So also make sure the firmware repository has free space, because some of the files in the image, they're compressed. So you're going to expand or extract. So free space, I believe you should have at least 25% free space. But before all that, before you start scheduling or doing the ad hoc maintenance, very, very important. The APIC itself is a server. The server itself has some dependencies on hardware, the firmware of the hardware. So you've got to be careful. Make sure you have the right release of the APIC and the right versions of for your switches. Now you can typically remember when you upgrade the APIC, if it goes down, will it affect your data plane? What do you think? If the APIC fails, will it affect the data plane? Thank you. The answer is, of course, no. It's only a management device. Now, if it goes down, do you think I can move a server either vMotion or physically unplug it from one port and move it to another? If it goes down, can I move? Can I vMotion it? What do you think is involved in vMotion? Who does vMotion? Network engineer or the server admin? Can I vMotion? Leaf 1 has host A, the host, which has VM1. Oh, come on. Can I vMotion? Who does this aspect of vMotion? VM1 from Leaf 1 to, what is wrong with my tablet? To Leaf 3. There's a host there, host B. Who does vMotion, by the way? Is it a network engineer or is it a network server admin? So we're going to pretend that there are 4 leaves, there are 2 spines. I want to, the server engineer tries to move this right here. Will that work? Server administrator does this, right? Thank you, Tom. The vMotion is done by the server administrator. They move it. Now the question is, if the APIC is down, will it work or not? Everybody's saying yes. Well, let's think over it a little bit more. APIC is the device which tells the switches, okay, what policy to download, what policy to download into the switch. Okay, so VM1, let's say it belongs to web EPG. So any policies pertaining to web EPG will be in leaf 1. But leaf 3 doesn't have any web EPG. So if the server administrator moves this and none of my APICs are up, of course, the answer would be this move is not going to be successful. You got to remember the APIC steps up when any move is made, any change is made on the device also. On your endpoint, they're moving around. If the APIC doesn't have knowledge about it, it will not convey that to the switches. So it is crucial. The APIC has to be up, even though it is not involved in routing. It's not involved in forwarding the data. It's the one which decides what policy should be pushed to the switch. APIC not there? No, you cannot move the devices around. You cannot move them physically or vMotion them. Not going to work. So just be aware of that. True, Cisco is very clear about this, the fact that it's not in the control plane, it's not in the data plane. But one thing we don't mention ever is the fact that if the APIC is not there, how do switches know what policy should be downloaded? They don't know. Okay. I experimented it long back. Actually, the only reason I make effort to mention it is purely because I took Cisco at its word when I was told APIC is not in the control plane or the data plane. Sure, it's not running a routing protocol, no data traffic flows through it. Okay, but if I have a switch which says deny to everything, don't talk to anything, how does it know what is to be permitted? Because the APIC has to push policies to it. And if the device APIC is not there, it will not push policies. The key to this product, you may even observe, okay, some of you may not have noted, actually the VRF gets created on these leaf switches only when it detects the endpoint. So you can't, even if you are here and you configure 10 VRFs, that doesn't mean all 10 VRFs get created on my leaf switches, on these switches. Okay. It only gets detected or it only gets created. In other words, things get instantiated on the leaf switch based on endpoints detected. Policies are pushed based on endpoints detected. So that's the reason I actually had this issue long back when I started working on it. I just took Cisco for their word and I shut down the APICs in a lab environment just to see whether everything was working fine. I did a vMotion and realized it didn't work. Of course, I didn't physically unplug. I just did a vMotion because I had all virtual machines. And then I dug deeper. And then it dawned on me, oh yeah, that so-called VRF was not even created on my Leaf 3. In fact, that's what happened. The VRF also was not created. So you've got to be careful about this understanding of this product. It is a little more complex than what you see. Questions? Felipe, there is absolutely redundancy because how many servers should you have in an APIC cluster? What's the minimum Cisco mandates?
3?
3. So what are the chances all 3 would fail?
Okay, got it. Okay, thanks.
I just asked a generic question just to make sure you understand the concept. Yes, it's not in the data plane, not a control plane product, but it is very much needed for endpoints when they attach. It's a crucial entity. External networking. Sometimes the word external is misleading. Many people think it's the internet. The minute you hear the word external, people associate with the internet. Well, here they are saying connecting to anything outside of ACI. Okay, connecting to switches or routers which are non-ACI capable. Why? You may have to connect to an existing data center. You may have to connect your leaf to a campus core. You may connect it to a WAN router. So all of that is considered external. That means it could be a layer 2 or a layer 3 network that is non-ACI, anything that is outside of ACI. Connecting to an existing data center, an external network. Well, layer 2 means it's doing bridging. Get used to the term bridging, which is of course switching. Layer 3 means it's doing routing. Layer 2 means bridging. The same broadcast domain, the broadcast domain is becoming larger, that's layer 2. Layer 3, it's a completely different broadcast domain, a completely different flood domain. Okay. Very crucial to understand this term, inside and outside. Inside refers to all your spine switches, your leaf switches, your APIC controllers, all those gray fabric connections, all of these fabric connections. That's also part of the inside network. Your spine switches, your leaf switches, all the IP networks that you configure within the APIC as subnets of the bridge domains, they're all considered inside. So what's outside? From the ACI's perspective, a connection that is okay. So example would be any network here. That's a layer 3. Okay. That would be a layer 2. Anything hanging off here. Any IP networks which don't reside in your ACI Fabric would be considered outside. That means anything outside the ACI APIC's direct knowledge is termed as outside, or anything it doesn't control is considered as outside. Now, there it says, routes learned from peering routers. I am going to say peering layer 3 entities. Because peering devices, device running routing protocol need not necessarily be a physical router. Any layer 3 peering entities, any routing updates received from them are known as the outside networks. So in this particular example, it shows you that a packet originates from an endpoint that is, so maybe this is a 10.3.5.x. And on the APIC, suppose I have the APIC here, we have a bridge domain which has a subnet 10.3.5.0, and of course the default gateway is specified. Well, this is considered an inside IP. It originates from an IP space which is defined within the tenant. The source is an inside entity. Well, my leaf is going to look at the destination. What is the destination is a 10.3.8.12, and the bridge domain, that's bridge domain 1, bridge domain 2 has 10.3.8.0/24. Destination is also an inside entity. Well, if that's not the destination, not defined in the APICs or tenant space, let's go with the destination 192.168.5.3. Of course, I shouldn't be including the math, but I'm just going to go ahead and say that. Then it's going to use the table. It's called the longest prefix match table, which has all the outside entries. And that's going to specify, for example, this as the border leaf. A border leaf is one or more leaf switches which connect to peering layer 3 entries, layer 3 devices. So basically it's forwarding it to the VTEP of the border leaf. So the forwarding space that is used, well, it's an inside IP, belongs within the tenant space. It's basically going with your global station table, identifies the VTEP or sends it to the spine and goes from there. Doesn't belong to the inside IP space. Let's go ahead and look at the outside networks. Send it to the border leaf. The border leaf will send it out. So we have two types of external connectivity. Layer 3, it's a layer 3 hop based on routing exchange. Routing exchange could be done using one of these protocols. Notice clearly we do not have ISIS as a routing protocol that you can use for exchanging routes with routing peers. In the ACI GUI, this is known as an external routed network. Then layer 2 connections is a bridged extension outside the ACI. Could be using VLAN or VXLAN. It basically takes, remember, internally, we're always using VXLAN encapsulation, or I would say eVXLAN. And externally could be VLAN. And of course, it could be even over a VPC. This is usually always used for a migration path. In the Cisco ACI GUI, we define them as external bridged networks. External routed network, when you're exchanging routing updates. Bridged networks, when you are just extending your existing broadcast or flood domain. I like to use the word flood, not the word broadcast. It's not just the broadcast. Now, I don't know if this is a good diagram. Okay, if you have multiple tenants, you have many approaches to identify each tenant over the same physical interface. That means you want routing updates for tenants to be exchanged over the same physical interface. Of course, this one shows you that you can go ahead and have each tenant uniquely identified by using VLAN tags, 802.12 tags for sub-interfaces or SVIs for each tenant. That's one option. Not a best practice nowadays when you have multiple tenants. Okay, there's a different approach for multiple tenants. This is one approach that used to be the only approach earlier. Identify each tenant with sub-interfaces on a physical interface or configure SPIs with different VLAN encapsulations. There's the GUI of how you configure your external connections. Everything falls under networking. This would be the layer 2 extensions. This would be the layer 3 extensions. Okay, that's where you configure the external bridge networks. This is where you configure the routed networks. And then all the devices that are accessible through that layer 3, through those layer 3 devices would be configured as part of external EPGs. And all nodes reached through that layer 2 connection would be part of external EPG under the bridged category. Okay. That's just highlighting where in the GUI you would be configuring the. And in the GUI, once you go ahead and configure and you allow the application, by the way, here's an example. Once you configure those connections, you can see an example over layer 3. This is a VRF, by the way. This VRF has a layer 3 connection and another one. This is another VRF. This particular tenant seems to have 2 VRFs, see? It shows you the topology diagram when you look at the networking folder. It's a network view relationship between the VRF, the bridge domain, any layer 2 connections, any layer 3 connections. And this is actually showing you the contracts. They've actually shown you a topology view once the contracts have been configured. So it's a policy view once the contracts have been configured. Shows you that these these are allowed to, they're actually consuming a contract or providing, that's actually provide arrow, providing a contract which is being consumed by the EPG. By the way, the arrow of the directions also show whether it's a provider or consumer relationship. Provider is usually the server side, the consumer is usually the client side. The entities which initiate the communication would be termed as the client, or they are the consumers. Let's look at the layer 3 networks in particular. How do you pair 3 types of interfaces on a border leaf to connect to an external router? You can use a physical layer 3 interface. You can have a layer 3 interface with sub-interfaces with 802.1q tags. That means it's the second one they've shown you here. Each one of them could be for a separate tenant, or you can use SVIs. That's the third one shown here. SVIs are ideally used when you want to use the same physical interface for bridging as well as switching. Layer 2 as well as layer 3. That's when you do SVIs. You remember why we even use SVIs. And of course, again, in this case, each encapsulation or each VLAN represents a different tenant. So what's the underlay routing protocol in here? Thank you, Greg. ISIS. Okay. What was the purpose of ISIS? Build routing table, at least the main purpose, and then of course it has additional reasons for every VTEP reachability. In other words, it's a bunch of routers connected in this manner, right? Because they're all IP addresses, a bunch of routers connected in this manner. We need a routing protocol, it's ISIS, and it helps build a routing table, how each of these nodes can get to each other. VTEP reachability. That's what ISI's responsibility is. That's why we call it the underlay routing protocol. Now, on Monday, as part of the instructor lab 1, I have only one spine. I enabled it to be a route reflector. Everybody familiar with route reflectors, right? I enable the spine. By the way, you can only enable a spine to be a route reflector. I enabled a spine to be a route reflector. The minute I enabled it, it actually, not only when I click that in the GUI, it actually does multiple things in the background. It enables BGP, not only on the spine, it enables BGP, I'll be more precise, MPBGP. And if I had to be more accurate, it is MPIBGP. That means these are all considered in one AS. The minute the only thing I did in the GUI was I selected my spine and said become a route reflector. Now, as soon as I did that, of course, it enabled BGP on the spine, made the spine the route reflector. It also enabled BGP on all my leaves. Every leaf becomes the route reflector client. And it starts exchanging BGP. So if I will go ahead and say show IP BGP sessions on my spine, I would see 2 sessions. You saw me navigate through the GUI, look at the sessions on the spine. It actually showed that it established 2 sessions to each of my leaf switches. Purpose, why did I enable BGP, route reflector? Routing updates. This is the core reason. Routing updates that you receive from the layer 3 peer could be OSPF, EIGRP, or BGP. They get redistributed MPBGP. Remember why it has to be MPBGP? We are talking about multiple tenants, multiple VRFs. So they're all one AS. These routing protocols are only used with the peer. Other than that, once they're distributed, how does that route, if I had a route here, 192.168.5.0, that doesn't show up. Suppose I was using OSPF. On this switch, it doesn't show up as OSPF. 192.168.5.0 will show up as a BGP learned entry. And you don't have to configure the route redistribution. It automatically does that for you. Okay. If you want to, you can filter what is sent into the fabric by BGP, what is sent in the advertised in the outbound direction. Those you can. Import filter route maps. In the outbound direction, you can decide, hey, I want to advertise a default route. I want to advertise only my internal IP routes. I want to advertise the ones that are learned also. Okay. So automatically redistributed to your leaf switches. I'm going to be a little bit more specific. Automatically redistributed to the leaf switches where the VRF is instantiated. Suppose this is feeding into sales VRF. That's the VRF where the routing updates are being received. Oh, sales exists here. Sales exists here. Sales exists here. That's where the VRF got created. Now remember, you must remember something. I cannot SSH into the switch and say, I want a VRF called sales. Who decides whether the sales VRF should be instantiated on these three? The APIC. How does the APIC decide? Based on the endpoints that connect to it. So updates received into sales, sent only to leaf 2, leaf 3, leaf 4. You shouldn't be worried that it doesn't show up in leaf 1, leaf 5. That's exactly what Cisco intended. Then, what is transit routing? I've got to mention what transit routing is because releases prior to 1.2 did something called stub routing. Stub routing. Okay, that's why I say it's an extension. What exactly do they mean by stub routing? Well, by default, if I have updates being sent here, this is a network, let's say 192.168.5.0. It propagates to the spine, spine sends it to the leaves, presume. This leaf shows it, 192.168.5.0 is there here, but it does not, by default, did not propagate Why did they not propagate it? They did not want traffic. They did not want that. So Cisco initially said it's going to be a stub network. Of course, a lot of companies said, no, leave it to us. Let that be a choice given to us. What if we want to use the data center as a backup path between some routing domains? What if we want to? True, we should not use the data center as a transit hub, good practice, but what if we want to, as a backup path, as a third backup path? That's why this is specifically mentioned. You can do it, transit routing. perform bidirectional redistribution between different routing domains. As part of what you redistribute outbound, you can decide. Default route, the transit routes, only the subnets that are here defined in the APIC, and they have to be defined as public. Okay. Now, if you're not using a default route and you are specifically having it send out routes, you can use outbound route filtering to say, hey, these are the ones we'd like to advertise through this particular layer 3 connection. Now, by default, all the networks that are defined within the bridge domains of the APIC or the tenant, they're not advertised externally. They are not. If you want to, you actually have to mark them. You see how this one is marked as public? Then it's going to go ahead and advertise it out. This is going to be learned through OSPF, redistributed into BGP, and then, of course, it is going to receive it on that leaf. So only public. It's actually a checkbox you're going to enable on the subnet. I will just summarize what I just said. As soon as I enable a route reflector, MP IBGP is automatically enabled between all the leaves and the spines that are configured as the route reflector. So, shall I call this, if you were looking at it from an OSPF perspective, that would be an, what's that? What does that terminology stand for? Anyone remember having learned what an ASBR is? Usually taught in the route class, right? Yeah. So that's actually very specific from an OSPF perspective. They have that terminology used quite often. Stands for Autonomous System. Yes, that's correct. Type 5 LSAs. That's correct, Felipe. That's type 5 LSAs in OSPF. Autonomous System Boundary Router. Okay, that's why I use that term. From an OSPF, if you were looking at OSPF, this is an ASBR. It's actually taking the routes right here, which are internally ISIs, and redistributing them here. The internal subnets are being redistributed. It's still an ASBR because it's taking the 200 into OSPF and redistributing to BGP. Where is EPGP here? I don't have EPGP in this example. There's only OSPF and I and PBGP. Oh yeah, you can assume it as the term autonomous system is usually associated with the AS number of BGP. Okay, let's look at the configuration aspect. When you're configuring layer 3, external layer 3. By the way, nowhere here they show you how to configure route maps and filter the routes. We're just assuming that you know what that is, and then it's done in the GUI, okay? They don't show you all those details, because assuming that you know all about the protocol itself, you should know about the different protocols and their details, so you can troubleshoot the protocol. So this class doesn't go through the protocol specifics. It just talks about how you're configuring and how the concept works. So you're going to configure under the networking folder in the GUI, okay, layer 3. That's where you go ahead and configure your protocol, which protocol, your type of interface. We have already done this, so you should have already done this at some point, configured your spine and specified. It could be, I would say, at least 2 spines, okay, as route reflectors. If one fails, you still have the other. And also the AS number for your MP IBGP. Should do this. On your subnets for the bridge domain, you've got to designate them as public. And then when you configure the external layer 3, it will ask you to configure the external EPG. That would be all of these networks. So if I do have a network here, and another one, so I have these. And then when I configure the external layer 3 EPG for this particular layer 3 connection, if I specify the subnets as 201.1.0/24, 201.2.0/24, I'm basically telling that these, when we establish the contract, you need a contract to communicate. They only can communicate with this, not possible to communicate with this, because I forgot to specify. I could go ahead and say I have a quad 0 network. That means all networks, 000/0. I could do that as my external EPG. Okay. So, and then there it is, the last one. Apply the contracts to communicate with those external EPGs. One or more. Here's an example showing you OSPF peering. They've actually selected OSPF as the routing protocol and configured the area number. You can configure a lot of the OSPF properties here, the type of area and so on. So that's what they're doing under external routed networks. You may have seen me doing the route reflector in an earlier lab. Here in this example, they're configuring the routing protocol BGP. Remember, based on the choice of protocol, there's a checkbox asking you which protocol. The options here will change. So they chose OSPF, the options here change. Chose BGP, the options will definitely change. Gives you a set of like BGP options like next hop self, allow AS. You can do MD5 authentication with OSPF as well as with BGP. We choose right there. Do you want to send the extended community? Do you want to send community? Those are because we select BGP as your peering protocol. Right there shows you how you configure under system settings, system settings, route reflector, configure the AS number, and one or more spines as your route reflector. On your IP subnets within the bridge domain, scroll down until you find the section to choose. No, there's no checkbox here. I'm not seeing it. They got the wrong screenshot here. Let me see if they have the screenshot anywhere else. No. It's actually a checkbox which says that you'd like to advertise. So you can see it. It says advertise. Okay. They're verifying it, but it's a checkbox on that IP subnet. Right now, it's just a verification. You'd like to advertise the IP subnet 10.0.1. They are right there. External EPG, notice it's a quad 0. All IP networks. And then you would have to apply contracts. The contracts tab is here, by the way. With this external EPG, you want to go ahead and apply the contracts. You're going to do that. Yeah. And look at the next type of connection, which would be layer 2. Connections to the fabric could just be a simple bridged connection. There are two ways to achieve this. It depends on the level of granularity you want for permissions. So if you have these devices, a lot of devices past your layer 2 connection, a lot of devices here, and you want to control a specific contract, or as they say, a specific policy. Policy would be more what dictates the permissions and the layer 4 to layer 7 devices and the QoS settings for traffic into the fabric and towards host past these switches. You would then use what is called extending a bridge domain. So this lets us create an external, multiple or one external EPGs. Okay, so that essentially means all the hosts behind your layer 2 switches, these are the layer 2 switches, they would be in an external EPG, even though this is a layer 2 connection, a VPC or a layer 2 connection. Even though it is, they will be considered an external EPG, which means you would need contracts. To communicate with other application EPGs. Versus the other option is we already have a web EPG, already have, configure this port statically. So there's a web VM. Configure the port statically, identifying a specific piece of hardware that's a static port to web EPG. So we're not creating a new external EPG. We already have one. This is an existing EPG. And we're binding the port. This is more simpler. We are saying any traffic coming in on port E1/12 will be tagged with VLAN 50 and will be assigned to web EPG. That's more simpler to accomplish, but it doesn't give you control over the contract. You're not establishing a new EPG for all devices connecting through that port. You're assigning it to an existing EPG. This is just extending the EPG. And of course, the other one. Now, keep in mind, in this example, they've shown you a server, but it could have been a switch. Okay, so this could have been a switch here. And you could have said, I want all traffic coming in through here to be tagged with a certain VLAN and assigned to. That means all the hosts here, A and B, their traffic, when they ingress into ACI, would belong to web EPG. That's what it means. Okay, a layer 2 bridge domain, you want to specifically configure for one. It allows you to create an external EPG. So based on the need, how your enterprise would like to control the communication, that's how you're going to specify whether you want to do a layer 2 extension of an EPG, or you just want to go ahead and do a layer 2 extension of your flood domain. And there it shows you it's a static binding of a link into an EPG. Traffic that this port receives or transmits is subject to the policy of the existing EPG. It's the same mechanism that you would use for bare metal servers. By the way, here is an example where they've shown you a switch. This one's just showing you servers which are statically bound to any endpoint belong to that EPG. It's simpler to configure. The second approach, extension of the bridge domain. You are telling ACI that your bridge domain is outside. That means your flooding domain also includes other devices out of this layer 2 link. So it lets us create a separate EPG. A more granular contract is needed. You can see how the contract is shown. Right there, they've shown you an external EPG, and you need a contract to communicate from here, or if you need an application, you will need a contract to communicate that. This is a little bit more difficult to set up. A little bit, not too difficult. A discussion about the spanning tree. Now think about it. We already arrived at one conclusion. This is an IP network. Or I would say a layer 3 network. And I have ISIS protocol here running. Do you think these switches are going to send spanning tree BPDUs? What do you say? I would say no. It's not layer 2. It's not switched. It's a routed network. So of course not. Those switches are going to be sending spanning tree BPDUs on routed links. Whereas in this part of the segment, we do have spanning tree BPDUs. And technically, if these are both in the same EPG, we would need, it might send traffic this way. So we've got to have some form of BPDUs circulating somehow, so it will prevent loops. So loop prevention has to be addressed. Okay. So what ACI does is if it receives spanning tree BPDUs, it will propagate it to any other ports which have the same EPGs. So you can see how those BPDUs are encapsulated in VXLAN. By the way, there is the feed called VNID. Okay, let me identify. Whenever packets are being routed, the VNID ID is actually an ID given to the VRF. Okay, when they're being bridged, the VNID is an ID given to the bridge domain. What do I mean by routed or bridged? What's the difference? What do I mean by that? How does our ACI determine should it route a packet, should it bridge the packet? How does this switch? So example, let's say I have a frame coming in. This way, there's a frame coming in. This is my ingress switch. Should it route? Should it bridge? Depends on the destination. Okay. Let's say it's coming in from A and for B, which is attached to L5. They're in the same VLAN. IP address is, this is IP 10.5.3.10, 10.5.3.11. What's ACI going to do? Bridge it. Let me pretend as if this traffic, A belongs to, I'm going to pretend this is web EPG. And this, you may wonder how it's possible. Yes, it's possible. Two different IPs of the same subnet. This is an app EPG. They're in two different EPGs. Felipe, you are right, but let's make that decision. How does the switch make that decision? Now, here's one thing we saw in the flow chart. That was something very, very important when we discussed the flow of packets. Okay, we discussed flow of packets. One of the first criteria is the switch trying to determine whether it should be routed or switched. In other words, okay. Now, if the packet's destination MAC destination MAC is SVI MAC address. Okay. If the destination MAC is the SVI MAC address, it's going to be routed. All other cases, it would be switched. Destination MAC address is the SVI's MAC address. It would be routed. In all other cases, the ingress switch, your L2 switch, will decide to switch the frame. Okay. So the VNID field, which is actually a VXLAN header, if it's routed, VRF value. If it is bridged, it's the bridge domain. In this case, this is a spanning tree BPDU, more like a control plane packet. It's really not a data packet. So BPDUs, the VNID value is EPG. By default, the switch L2 is going to examine the frame, notices it's a BPDU, encapsulates VXLAN header with VNID equals EPG. Send it to every port that is identified belonging to this EPG. So in this example, you can see how it gets to this port. So we have a method of making sure the spanning tree, and thus it can prevent loops. It blocks the redundant link. You can, now some aspects to BPDU flooding. It's always on, but you can actually go ahead and configure an access policy for this port with a BPDU filter, BPDU guard on select ports. And also, it's always remember, BPDU flooding is on by default. You cannot disable it, but you can put access policies with BPDU filter and BPDU guard. BPDU flooding is different from data plane flooding. The data plane flooding, you can turn it on and off. We had broadcast, you want to flood it, you want unknown unicast, you want to flood it. You have the option, but for BPDU flooding, you cannot turn it off. All you can do is do BPDU filters or BPDU guards. Well, flooding is on. You just need to be careful here. Just in case somebody accidentally connects these two switches, you want to make sure we have BPDU guard turned on the access ports. Okay, there shows you the VNID field will be the EPG for which the BPDU is being transported. Next comes topology change notification, TCN bits. What is TCN for? What's this? Thank you, Derek and Victor. It's a 1-bit field. It's either a 0 or a 1. When it's set to a 1, that means there's some topology change notification. So Ethernet switches, typically, whenever they see BPDUs with the TCN bit being set, what they do is they reduce the aging timer for the MAC address. Okay? So it's basically going to make sure that we don't have unnecessary traffic flooding towards MAC addresses which don't exist anymore. Okay? Reduce the aging timer. Now, in there, it shows you typical reaction of Ethernet is to lower the MAC address aging timer. But what does APIC switches do? APIC flushes the MAC addresses for that particular EPG. So if it detects a TCN coming in, there's a web EPG, BPDU with TCN bit set. Right, the APIC is going to flush out the MAC addresses for that corresponding EPG. Now, flushing out the locally learned MAC addresses means the switch will now have to go ahead and rebuild the local station table eventually again. So flushing is not a good thing. Flushing the entire MAC addresses for the EPG is not a good thing. How could we prevent it? Maybe have a port channel or VPCs. Okay. By the way, if you do use multiple spanning tree protocol, multi-spanning tree protocol, you would have to manually configure the instance. That's why it tells you that with MSTP, the instance to VLAN mapping, you have to manually configure it. There are two ways to go ahead and minimize these TCN notifications. One is use some form of VPC. Okay. Then the other way is, just ensure that if you do have redundant links, the VLAN that is used by the switched, suppose I have a redundant link here and not right there. I would like to make sure that none of the servers which are directly connected are not using the same VLAN. So suppose VLAN 10, VLAN 10, maybe VLAN 20 also. I would like to make sure the servers that are directly connected, any MAC addresses learned are not flushed out. So I would say do not use VLAN 10. Okay. Minimizes the impact of flushing out MAC addresses. As far as local loop detection, we know that ACI does not use spanning tree protocol. So how will it prevent local loops? Well, it has a cable plant verification protocol all the time enabled. Checks if a leaf node is connected to a leaf node, shut it down. If a leaf node is connected to its own port, like in the first leaf, shut it down. It has this cable plant verification automatically turned on. You cannot turn it off. Okay. It will automatically turn off those ports. So configuring your layer 2 networks shows you how you're going to go about configuring them. Here shows you select your EPG. You want to add static ports. You can do that. Statically assign a port to the EPG. An entire node. You can add a MAC address. So that's basically saying I want this particular MAC address only to be assigned to this EPG. I want all ports on this node with a certain encapsulation to belong to the EPG, a specific port. That's how you extend an EPG to a static port or to a whole leaf node or to a specific server MAC address, creating a layer 2 bridge domain, which will eventually lead to creating a new contract also. There it shows you, you're going to be specifying the external bridge domain. You're going to specify that. It will reference a VLAN pool, leaf ID, that's the switch ID, the interface or the range of interfaces, the policy group. Policy group actually has the attachment point, which connects it to the bridge domain, which specifies the range of VLANs. Okay. Now this bridged domain is going to be configured as an external bridge network. And also specify the external EPG below that. So here is a snapshot of the external bridge network configuration within the networking folder of your tenant. You're going to specify which bridge domain needs to be extended. Okay. Which bridge domain needs to be extended. You're going to select the bridge domain. Specify the encapsulation. Right there, the EPG has been already configured. They've already shown you the EPG is configured right here, external EPG, and they're applying the contracts, either a provided or a consumed, depending on where your server resides.